Okay, hi guys, this is homework 7 and for the probability and the stochastic process. And I'm Jianfeng Zhang, and this is the problem 7. Okay, and in this problem we have seen that we have got a random process here, right, like a sine and cosine form, and which the R and random variable of theta is uniform distributed in the 0 and 2 pi. And also we have known that the n1t and n2t are all WSS. So, and also we know n1t and n2t and theta are all independent. So the first we should find the expectation and find the RZ, and we need to find whether ZT is WSS. And third question is we need to find the R0 or RZ0 if ZT is WSS. And we know that if N1T and N2T are WSS, then their expectation are very easy to see, that the expectation of the N1T is just sigma t and theta t, and also the n2t is also theta 2t, and also these two expectations are not functions, they are just constant. And so after we calculation little about the expectation, and we put that function into the expectation, and after that we can figure out that the expectation is 0, and we can figure out the expectation not 0, and it's very simple. And in the second question, we have seen that the RZ T1 and T2 equals to, we use the definition, and we can write like this. And if we put away all the times, and we can write like this: for kind of function multiplication. I will not read this because it's too complicated, and we just write these four functions and we made them plus. And we can see that because RT is equals to xt plus tau times xt in this expectation, and we assume that tau is equals to T2 minus T1. And so after that, we have figured out that the RT1 and T2, we're using this kind of this whole plus, and we can figure out the RZ is equals to half of the Rn1t minus Rn2t, and times with cosine t. So we can see that the RZT1 and T2 equals to RZZ. So, and also we found that the expectation is also 0, so we can figure out that this is constant, so the ZT is WSS. And in the last question, if ZT is WSS, we must know that the RT is just equal to its square expectation, like this. So that's all. And in the second question, this is the Poisson process, and we know that Poisson process is written like this, and we also know that the expectation of Poisson process is equals to lambda, and the derivation of the Poisson distribution is also equals to lambda. And what about the process? And if the process is written like this, and here is a xt, we know that the process, the only difference with the process and the constant distribution and the random variable distribution is that the distribution is a special condition of the process. That is, if the t is fixed, then xt is just a Poisson distribution. So, and what about there is a t? So we can easily find out the expectation r lambda times with t, and the expectation of the two moments are lambda t times with 1 minus lambda t, and the derivation is lambda t, also lambda t. It's just times a t to the regular Poisson distribution, and it's easy. And also in the second question, we need to find out if what is the RT1 and T2. So we need to figure out this kind of conditions. That is, if the time period, uh, if the time period in these two time periods they are overlapping or not overlapping, and we know that N1 and the two time periods are both independent. So we know that if T1 is smaller than T2, and these two time periods are not overlapping, so and also we know that it is independent, so therefore it is easy to find out in this Poisson. It is a Poisson random variabilities, so it has parameter with lambda T2 minus T1 and lambda T1. So is it easy to find out? We can write R T1 T2 using expectation form. So we can write like this, and after we know that like this, we just put the result we have got in the first problem. These three results put into these functions, so we got the final RT1 T2, and so this is the first condition for T1 T2 are just not overlapping. And if T1 T2 equals to T, and also if we can use these two results to go to the question, and it's much more easier, so we get this result. And moreover, if T1 is bigger than T2, it is similarly that we got R T1 T2 is can be written like this. Okay, that's all. Thank you.